Okay, we're continuing Chapter 2 on polynomial functions with Section 4, which is about finding maximum and minimums of polynomial functions. And so the objective here is to write a polynomial function for a given situation and to find the maximum or minimum value of the function. Okay, so what are maximum and minimum values? If we have a parabola that's opening upwards, means the lowest value we can find here is a minimum. There is no maximum. So if we have a parabola opening downwards, you can see there's a maximum here. Other graphs we looked at recently are x to the cubed, which you can see we have a maximum and a minimum. Another graph we've seen is x to the fourth. So if it's something like this, there's could be two minimums, right? But this one isn't the lowest. This one is. So we're going to say this is our minimum. Okay. So example 1. Find the maximum or minimum of the following polynomials. So given this polynomial, the first thing you're going to want to do is graph using your calculator. Okay, so opening my calculator, I already have 3x squared plus 2x minus 6 already in there in my y equals. So all you have to do now is second trace. Oh, actually graph. We're going to graph. So as you can see here, there's going to be a minimum. So to find that minimum, we'll do second trace. So if we were finding a maximum, we would press 4, but we are finding a minimum, so I'm going to press 3. Now it says left bound, so we want to be to the left of where the minimum value is going to be. So moving my cursor to the left, now you can see I'm to the left, so I can press enter. Now it wants me to move to the right. Press enter. Now we can guess, so enter. Now it says our minimum is that x is equal to negative 0.33. And our y was what? Negative 6.33. And all you can have to do now is write minimum, and that is what our minimum is equal to, this here, negative 0.33, negative 6.33. Okay, move 2, it says a rectangular dog pen is constructed using a barn wall as one side and 60 meters of fencing for the other 3 sides. Find the dimensions of the pen that give the greatest area. Okay, so we kind of have a lot of information here. We're just going to break it down. So we know we have a dog pen that's rectangular and the barn wall is one side. So first I'm going to just draw the barn. Just going to take up one side. Then it says there's 3 other sides and they're going to be 60 meters of fencing is what we have to use. Okay, so we know we're looking for a greatest area and we have 60 meters of fencing. Okay, so let's see. What do we know? We know for a rectangle, if we don't know the value, we can just say it's x. And of course, these are going to be the same because for a rectangle, they have to be the same. And now we have 60 meters of fencing, but we have x plus x, which is just 2x. So of the fencing, we have 60 minus 2x is what we're going to have left to use to find how much fencing we need for this side. Okay. Now another thing, it says we're looking for the area. What is area? Area is length times width. So now we have some dimensions here. The length we'll just go ahead and say is 60 minus 2x. Okay, that's our length, and our width is x. So multiplying those should give us our area. And now that we have an equation, we can just use our calculator to find, it said greatest, so we're going to be looking for a maximum. And down here I have that equation, 60 minus 2x times x. So if I turn this one off, that graph that we plotted before, and I turn this one on, graph, okay, can't quite see what it is, so we're going to have to change our window. Let's move to the right some. So if we change our x max to, let's guess, about 40, and maybe our y max a little, maybe 30, and see what we get. Okay, still can't see much, so I can see something here. So let's go ahead and try and find, increase our y max. Oops, window. Y max, how about 40? Oh no, let's try 50. Still not getting too much. So let's try to increase that much more. So how about 300? Almost there, a little higher, so let's try 450. Barely there, but we should be able to work with that. So again, second trace. This time we're finding the maximum, so 4. I want the left bound, so if I move to the left, you can barely see it up here, but it is moving to the left. Then you press enter. Now it wants my right bound, so if I move to the right, you can see it's on the right side of where we believe the maximum should be. So enter. Enter again for a guess. Now it says x is 15 and y is 450. So I'm just going to write that over here. X was equal to 15, y was equal to 450. So we were just there. So this value here, the y value, that's always going to be your max or your min. In our case, it's our max because we're finding the greatest area. Now be careful, because what this question actually was asking is find the dimensions of the pen. So while we did find the maximum, what we need is the dimensions. So we found that at the greatest area, the dimension for x should be 15. So all we have to do now is plug x is equal to 15. So x is equal to 15. If we plugged it in for this here, 60 minus 2x, that's all we had to plug in. So 60 minus 2, and x we said is 15. So 60 minus 2 times 15 is 30, is just equal to 30. So the dimensions would be 15 by 30. Or you could just say 15 and 30. Actually, I don't want anyone to get confused. So instead of writing the 15 by 30, I think it's just better to say that x is equal to 15 is one dimension and x equal to 30 is another dimension. Just because that 15 by 30 looks like we would be multiplying, and I don't want anyone to multiply. So the dimensions to make the greatest area would be x equal to 15 and x equal to 30. Okay, so example 3. We have another word problem. And so this section has quite a bit of word problems. I don't want you guys to get intimidated by word problems. A lot of people do, but the best way to go about it is just to read it once and then try to break it apart. So example 3 says, squares with sides of length x are cut from the corners of a rectangular piece of sheet metal with dimensions of 6 inches by 10 inches. The metal is then folded to make an open top box. What is the maximum volume of such a box? Okay, so we have a rectangular piece of sheet metal. So I'm just going to draw that here. then the first thing it said is squares with sides of length x are cut from the corners. So in the corners, I'm just going to draw a box of what would be cut out, and there's squares. And it said they would be length x. So all of these, the sides of the squares, would be x. Then what else does it tell? It says the dimensions of the sheet metal are 6 inches by 10 inches. Okay, so I'm just going to draw that. 10 inches by 6 inches. So then it says the metal is then folded to make an open top box. So if we had, imagine if we had cut these out, right? It said there were squares from each corner cut out, then we would have it folded at these edges and it would make an open top box. Okay. Then it says, what is the maximum volume of such a box? So volume, if you remember, is length times width times height. Okay, so now we have to see what our dimensions are because we would be cutting out these x dimensions. So it's not simply 6 inches by 10 inches. We're actually going to cut out 1 and 2x from this here. So this would be 10 minus 2x on that side. This side would be 6 minus 1 and 2, so another 2x, so it would be 6 minus 2x. And then the height of the box is just x, because it would be this side here. So if we write that out, the length is 10 minus 2x. The width is this here, 6 minus 2x. And then the height is just x. This side here, if you fold it up, it would just be that x value. Okay, so now that we have an equation, we can go ahead and graph. So I went ahead and put in the y equals the equation that we have. It's kind of broken up here, but I can show you 10 minus 2x times 6 minus 2x times x. If we graph, then you can see we're kind of missing some information. We're looking for a max, so we're going to have to increase to see where it peaks. So going to the window, let's increase our max, y max, to let's say 40. Okay, graph. Now, as you might notice, if we multiply this out, we would get an x cubed graph. And as you see here, it would peaks up. It's going to have a minimum as well. So make sure you're paying attention to what the question is asking, because I wouldn't want you guys to calculate that minimum. We're trying to find the maximum. So we're going to calculate that maximum there. Maximum is 4. Left bound. Okay, so I'm on the left of where the maximum would be. Enter. And right bound. Enter. Guess. Enter. So our maximum, it says, is at x equals 1.21 and the y is at 32.8. Okay, so I'm going to go ahead and write that. X equals 1.21. And y was equal to 32.8, I think it was. 32.8, yes. Okay, and remember, it's always our y value that gives us your maximum or minimum. So final answer is the maximum volume is equal to 32.8, and our units is inches. Volume is always cubed. So this is actually our final answer. Okay, we'll save this one for tomorrow. that was all on maximum and minimums, and I'll see you all tomorrow. Hope you have a great night.